Well, I'm starting to make further improvements to break away from Joseph Newman. And I think the first one was putting in this neon bulb where I put it. Now, if I go backwards and describe a little bit about the purpose of the capacitor is supposed to suppress arcing on the commutator. And that arcing always points in the direction away from the battery. In other words, it drains the battery. Well, once you put in the capacitor, you don't need the short anymore at all. Well, at least in this case with the neon bulb. So I took out the short and I got slightly elevated performance. I got more negative amps on the coil. I got more negative volts on the coil. I got more negative amps in the battery. I got more watts out of the spinning, rotating magnetic field. I mean, I got all kinds of advantages that I wouldn't have gotten otherwise. So it gave me more room on the circuit. Now there's other ideas I'm going to try out, but this was the first one, or the next one in the series. So I made it version 14, neon bulb without short, that actually adds a little bit of power to the thing. I didn't make any other adjustments. I just took out the short and rearranged things and then put up the new values of what I'm getting out of this. And it's pretty good. It looks very good, in fact. So I'm kind of happy with that. Thought I'd let you know. Oh, one other thing. I'm now targeting, my goal is to create, is to fashion this with the objective of leaving it as it is. In other words, this is solid state. There's no moving parts here. And that creates a challenge. What's this good for if you're not getting mechanical advantage out of it? Because that's all everybody, understands Newman's device to be, something that gives you mechanical advantage. So what would it be good for without any kind of mechanical advantage in which the whole thing is solid state? I don't have a clue. All I know is I've set myself a challenge because I like solid state. Solid state is good. But what's it good for? I don't know. And if you got any ideas, let me know. Because if you monkey with the circuit too much, the whole thing gets thrown off balance. And that's what I'm afraid of, is that things will get thrown out of balance. And it won't be a nice circuit anymore. So all I did was take out the short, and that was already an advantage. But still, what's it good for? So I have various ideas I'm going to try out that are a little out of the norm of what this might imply, just staring at it. Because I can think about expanding it. I see potential possibilities that I need to try out to see what happens. So maybe tomorrow, because I don't feel like working today. I did enough work. Anyway, I just thought I'd let you know. I'm still learning all the little features of trying to do proper screencasting with my new microphone stereo headset combination. So not only do I have to change the parameters inside my screencaster to acknowledge and use the input from this new microphone, I also have to turn my speakers off. I got two extra pairs of speakers actually coming out of the computer, and I have to shut them off to eliminate echo. Sorry about the last video, it had echo. So I've been trying to improve upon my simulation of Joseph Newman's energy device, and I'm getting nowhere. I cannot improve. So I doubled it. I created a spine. I imagined the capacitor is a spine, and then I just mirrored everything on the right side over to the left, and I found I got better results if I put the neon bulb on the left side rather than having it on the right. But so far I don't see any advantage. Oh yes, and I also offset this chopper down here by half a wave. The waves, both the square waves and the sine waves are 10 microseconds in duration, and I offset the waves down here, both the sine and the square waves, by half a duty cycle, so that when one fires on the left side, the other's at rest, and then the right side fires, and then the top side is at rest. So it's a push-pull situation. Didn't do anything. What I did do, though, is I'm trying to, I made a different format, a different layout. I like this layout much better. LTSpice doesn't do it for you. You have to do it by hand. You know, putting the circuit on the right and the waves on the left, the tracings, because you don't need too many waves, you know, like two duty cycles and it's enough. So I got 2 sine waves, you know. Oh, I'm missing a wave here. What happened to it? V out number 1. Whoopsie. Yeah, that's no good. And then we change its color. Well, what color do we give it? Oh, we make this one yellow. No, it's backwards. What am I saying? I learned a new trick. You take it out and you put it back in and then it gets behind it. Ooh, I'm so tricky. Let's see, yeah, this one is magenta. Alright. Yeah, this things disappear sometimes. Oh, it disappeared up here too. Okay, I'm going to have to redo a few things. So I'm making columns. Everything on the left is the top, and everything on the right here is on the bottom here, because I have 2 sets of everything. And here, the voltage in is the same in both cases, so this light cyan overrides the magenta because the magenta is underneath. As you can see, if I take it out, there it is, 300 volts, and that's the battery pack. Anyway, sorry. So what I'm learning is, you know, I never really understood RMS, and although I suspected RMS would be more accurate, the problem is RMS eliminates sine value, and we have to know what is the sine value of these different components and combination of components that, you know, I'm trying to find out, you know, what's the average over the course of these wavering waves that undulate up and down. And Dr. Hastings used averages because then he could retain the sine value and then make note of whether or not the battery pack was getting a negative charge or not, instead of draining itself. And that's a good thing. Problem is that averaging is not good unless you're just doing a DC, which, because it, you know, it's almost like saying nothing, you know, especially if it's a flat DC, you know, as opposed to rising or falling. So I really don't need an average here because, whatever, I put it in because it's just flat lines. But everything else goes up and down. And if you take a true sine wave and you take the middle, it's 0. And it's only when you take waves that are complex, that do undulate up and down like a sine wave, but are no longer a pure sine wave, that's when RMS really is a good idea. Again, the problem is, what's the sine value? What's the polarity? So what I did was, I did a combination of the two, and I'm going to do that from now on, because I want as much information as possible. So for instance, the average here on the battery number 1, the current, the average on the current is negative milliamps, negative 1 milliamps, while the RMS is a little over 12 milliamps positive. So I'm using the 12, but I'm taking the sine value from the average and adding it in to make it obvious here. Then I'm adding it back in because you're never going to have it when you take an RMS. RMS, you know, you take the, you know, it involves squares and square roots, and so you lose, or it takes the square. Root means square. So when you square something, you lose the negative value, if there was one. And I have to put it back in. So I use the average to tell me whether or not it was originally negative. And then, for the magnitude, I use the RMS. So I use the sine value of the average combined with the absolute magnitude, which it's going to be anyway, of the RMS, and I combine them together. So where it's positive, I don't say so because, I just assume if you don't say it, then we know it is. But to distinguish any kind of value from the positive, I add in this times -1 to indicate, well, yeah, RMS is always positive, but we have to include the negative to recognize that the current on L1, which is, where is it? Up here, is going in the backwards direction. It's going back to the battery, helping to recharge the battery, the current on this inductor. And I want to know that. I want to know which way the current is flowing, or the voltage for that matter. Now let's see, here's the voltage of the coil number 1. No, yeah, the voltage coming off to the side of the coil. And so this gives us the voltage on L1, out 1, and voltage out 1 is a negative value of 565 volts RMS. And that's pretty good by comparison to what the average is. The average, let's see, where's the out? The average tells us that it's a mere 51 volts as opposed to 565. So who do we go by? Do we go by the RMS of 565 or the average of 51? I like the RMS, obviously, because I'm going to want to show that there's lots of volts coming out here, because that's ultimately going to change my wattage. That's what my 3 rows up here are. This one's a little dinky because I missed out on the left-hand column. I don't know what happened to it. But I have the batteries, the wattage on the batteries here. So if we just take a look at one, we have, this is in joules though, 6 microjoules. So now I'm going to have to find out what is the integral of wattage giving us microjoules? What does that mean? Do I go with 300 milliwatts negative average, or do I go with -6 microjoules? I don't know. I'm going to have to read up on that, which one I go with. They're both negative, so I don't have to worry about that, but the absolute magnitude, yeah, I should worry about, because I don't know what joules are. I don't understand them. So I still got some more reading to do. So I'm trying to change how I go about giving these figures about the efficiency of the thing in its various components, so that I can give better knowledge. I can give more accurate information. And I like this layout because the formatting is good, for one thing. It's advantageous. And for another, how many waves do you got to look at? It doesn't have to stretch across the screen. LTSpice doesn't give you that advantage. This tile window business puts them above and below, and it will divide it if you have more than 2. But it won't give you just 2 side by side by default. There's no function for that. So, you can have cascading windows. I don't want that. So that they overlap. I don't want that. I just want them side by side. So that's an area for improvement. I guess I could complain to the company. Say, wouldn't it be nice to have them side by side? Have a function, have a little button for that? Let's see. So I have to, pull these edges around manually to put everything where I want it. And I like it this way. This is really cool. So I couldn't improve efficiency, although I thought maybe, well, it's going to be more stable because it's got a left-hand side and a right-hand side, or a top side and a bottom side in this case. I turn this thing around. Counterclockwise, I turn it 90 degrees. And then the capacitor is my spine down the middle. So I got a being. I got a left foot here and a right foot down here, and he's laying down. And it's a headless being. There's no head. It's got 2 arms out here, and it's got 2 testicles, or ovaries if you prefer, the neon bulb, 1 on each side. No penis. I guess that one disappeared. It's got a knee over here and a knee over here to help it walk, and it's got a foot over here and a foot over here. It's got some shoulders over here, and the basis for a neck, but no neck, no head. A headless giant. The headless electrician. It's got a heart right here, a capacitor, a capacity for heart. Oh. Oh, don't I have fun? Yeah, I love to have fun. Make up stuff. My imaginary friend. And don't take this voltage down here to be his heart rate, you know. Beep, you know, he's not dead. Far from it. Oh yes, and because he's getting an old alter cocker, you know, when he dribbles after he pees, and this text here is dribbling, you know, he's dribbling. A little diarrhea, a little pee dribbling, you know, he's getting old, you know, what do you want, you know? He's been around a few times, around the block a few times. Okay, I think I've said enough. I'm getting disgusting enough. So now you'll know if you've seen this video, you'll know what this graphic means. If you haven't seen the video, you'll be scratching your head and maybe scratching something else, and you'll go, what? What's this guy doing, putting a -1 times an RMS value? What's he trying to pull here? You know, he's already got -1 on this side. Why does he have it on both sides? Oops. Whatever.